Hello everyone. We're going to do a little bit of review about Unit 1.4, which is all about rigid motions and congruence. Basically, this whole entire unit revolves around the three types of rigid transformations, which are the translation, the reflection, and the rotation. In this unit, we talked about the algebraic description for each type of transformation, as well as how that looks on a graph. So what we're going to do is we're going to put this all together, and we're not only going to talk about those three types of transformations, but we're going to talk about sequences as well. So let's review some questions that might show up on a test. Question number 1 here asks, what is the coordinate of C double prime after applying the sequence of transformations? So, like it says in the question, we're only focused on point C. So we can actually ignore points A, B, and D in this graph. If we look carefully, point C is at -2, 3. So let's rewrite that down here. We're going to apply this first transformation to point C in order to get C prime. Then we're going to use C prime and apply the second transformation. So let's do that now. In order to find C prime, we need to follow the rule that we're given. So the first algebraic description that we're given is x minus 6, y plus 3. And that means exactly what you see here. We're going to take the x coordinate, -2, and we're going to subtract 6 from that. So -2 minus 6 gives us -8. Then we're going to add 3 to the y coordinate. 3 plus 3 is 6. So the result of the first transformation is -8, 6. Now we're going to apply the second transformation to obtain C double prime. This second transformation just tells us that we're taking both the x and the y coordinate, and we're just multiplying each of those by -1. So -8 times -1 is +8, because a negative times a negative is a positive. And +6 times -1 is -6. So our final answer is that C double prime is at the point +8, -6. And that's it. Let's move on to question number 2. Question number 2 says that triangles ABC, A prime, B prime, C prime, and A double prime, B double prime, C double prime are shown on the coordinate grid below. What we want to do is figure out what sequence of rigid transformations will map triangle ABC on to A double prime, B double prime, C double prime. In other words, we're just figuring out the two different types of transformations that we see on a graph here. In order to do that, we have to know which one is the pre-image and which ones represent the image. We should know by now that the pre-image has no marks, so I'm going to label the pre-image with the number 1. A prime represents the image after the first transformation, so I'm going to label that with a 2. If we just focus on figures 1 and 2 for now, you can tell just by looking at the graph that this is a reflection over the y-axis. However, while we can look at the graph and see that, we do have to confirm using actual coordinates. So let's choose point C to compare. Point C is at the coordinate -1, 3. However, C prime is at the coordinate +1, +3. If we think about what's happening here, we started off with xy, and our x coordinate just became negative. So we're going to rewrite that as an algebraic description. Our algebraic description should say that xy transforms into negative x, positive y. And if you know your rules, you should already know that this is representative of a reflection over the y-axis. Now that we have this done, let's talk about the other two figures, figures 2 and 3. Once again, we can compare points to see what's happening, or we can just look at our graph. In general, we can tell that figure 2 has been moved down and to the left. In other words, it's been translated. What we want to do now is figure out how many units we have translated this figure. So let's just count the boxes. Let's start at point A prime. We've moved down 1, 2, 3, 4, 5 units down. And we've moved 1, 2, 3 units to the left. So now we're going to rewrite this as its algebraic description. Whenever we're moving something to the left, we're subtracting from x. So this should say x minus 3. The same thing goes for when we move down. Down means we're subtracting from the y coordinate. So we should have the expression that says y minus 5. And, in fact, these are our two answers. Negative xy and x minus 3, y minus 5 are the two transformations that will map A, B, C onto A double prime, B double prime, C double prime. Now let's move on to question number 3. Question number 3 wants us to describe in words what transformation will map x, y, z onto x prime, y prime, z prime. In other words, we're just looking at the graph and we're figuring out what type of transformation happened here. So just by looking at this, I can tell that this is a 180-degree rotation. However, like I said, we need to confirm this by using a coordinate pair. I'm going to compare point X on the pre-image to point X prime on the image. Notice how 1, 2 is our X and our Y coordinate, but in the image, our X has turned negative as well as the Y coordinate. Therefore, our algebraic description should say negative X, negative Y. Since negative X, negative Y is the algebraic description of a 180-degree rotation, we have successfully confirmed that this is the correct answer. Let's move on to question number 4 now. Question number 4, just like the previous question, wants us to describe the transformations that are happening in this graph. So first, we have to start with the pre-image. I'm going to label the pre-image and the subsequent images with a 1, a 2, and a 3. So now let's focus on figures 1 and 2 only. We can pick a point just like we did earlier and compare them to see what has happened here. So if we look at point R, it's at -1, -3. However, R prime is at +1, -3. The only thing that changed here is that our x coordinate went from a negative to a positive. So if we start off with xy this way, we should end up with negative x, positive y. Negative x, positive y, like we said in the previous question, is actually the algebraic description for a reflection over the y-axis. So that is the first thing that we want to write down here. we want to write down that quadrilateral DHKR is reflected over the y-axis. Then something else is going to happen to it, and we need to figure out what that is. So we're going to focus on figures 2 and 3, and we're going to check the coordinates once again to see what's happening here. If you look at the coordinate of r double prime is at 5, 1. And if you think about what's happening with the coordinates, if we go from 1 to 5, that means that we added 4 to our x coordinate. Then, if we go from -3 to +1, that means that we added 4 to our y coordinate as well. Anytime we add or subtract from x and y, this is a translation. More specifically, if we're adding to x, that means that we're going to the right 4 units. And if we are adding to y, that means we are going up 4 units. This is exactly what we're going to write. So we're going to write then is translated 4 units right and 4 units up. So this is the answer to this question. Let's move on. This next question wants us to describe the transformation that, when applied, will map ABC onto A prime, B prime, C prime. So for this graph, we're not focused on the double prime. We just want to know what's the first transformation that's happened here. So once again, I'm going to mark with a 1 and 2 to show that this is the pre-image and this is the image. And we're going to compare the coordinates to see what happened. I'm going to choose point B, and we're going to figure out what happened here. Point B starts at 2, 4, and ends up at 4, 2. So let's think about what's happened here. 2 represents our x-coordinate, 4 represents our y-coordinate. If we compare these two coordinates, you can tell that the numbers have been switched, giving us y, x. But that's not the only thing that's happened here. The 4 turned from a positive into a negative. So the rule that we're going to use here is negative y, positive x. This is actually symbolic of a rotation. Now let's move on to the next question. This next question wants us to describe the sequence of transformations that will map ABCD onto A prime, B prime, C prime, D prime. Now, in fact, there is a sequence of transformations happening here. Keyword being sequence. That means there has to be more than one. So let's focus on one thing that has happened here. It's quite obvious that this figure has been flipped or reflected. More specifically, this is a reflection about the y-axis. So the algebraic description that we're going to use here is actually negative x, positive y. Again, this is a reflection over the y-axis. Now, if we were to truly reflect this over the y-axis, our points would end up somewhere here. But you'll notice that's actually not the case. This figure has also been translated down. So we've only went 1 unit down here. This should give us the algebraic description, positive x and y minus 1. Because there has been no change to the x-coordinate, however, the y-coordinate has shifted 1 unit down. And these two algebraic descriptions are the answer. For the next one, what we want to do is write the algebraic description using the coordinates. Just like we've always been doing, we're going to pick 2 points to compare, and then we are going to write down the algebraic description. Now, in this case, we don't have the distinguish between which one is the preimage and which one is the image. However, in the question, it tells us that we are using EFGH to create ABCD. What that means is that EFGH is the pre-image and ABCD is the image. So I'm going to pick 2 corresponding points. In this case, I'm going to pick point G and point C because they match each other. Point G is at the coordinate 3, 2, and C is at the coordinate 0, 1. Now all we have to do is figure out what happened here. So if we compare these 2 coordinates, to go from 3 to 0, we're going to subtract 3 from our x-coordinate, giving us x minus 3. And to go from 2 to 1, we're going to subtract 1 from the y-coordinate. So the algebraic description here should say xy transforms into x minus 3, y minus 1. And this is our answer. Now, last question. We're going to describe the sequence of transformations that has been applied to ABC to create A double prime, B double prime, C double prime. As always, we're going to label the preimage and the images with a 1, a 2, and a 3 so we know where we're going. This makes it easy because they already have the coordinates listed for us. So now we just have to figure out what changed here. If you look at our original point A and you compare it to A prime, you'll notice that we have subtracted 1 from our x coordinate and we have subtracted 5 from our y coordinate. So the first algebraic description should be xy transforms into x minus 1, y minus 5. Now let's compare this point to A double prime. If you look carefully, the only thing that's changed is that the x-coordinate went from a negative to a positive. So this should give us the equation negative x positive y. So all throughout this unit, all we've done is compare 2 coordinate points to determine the algebraic description.